The traditional idea of a life's work is defined by its duration. We imagine a monumental achievement requiring decades of dedicated, singular focus. Historically, achieving a scientific breakthrough or creating a masterpiece meant committing an entire adult life to the pursuit. But this timeline was rarely a choice, it was a constraint. Human potential has always been trapped behind a series of unavoidable bottlenecks that dictated exactly how fast we can move. This diagram shows the friction of the old model. Years are lost to the slow pace of manual data processing, the mental drain of administrative chores, and the fact that large-scale projects were only possible with the backing of massive institutions. What happens to human ambition when these systemic points of friction are removed? Today, the current convergence of advanced computation is dismantling the barriers between a person's ambition and its execution. The first major bottleneck is the wall of data. In modern research, the volume of information required to find a new drug or a more efficient battery material often exceeds what a human team can process in a decade. Machine learning acts as a hyperaccelerant here. By identifying patterns across vast datasets, it allows scientists to analyze results and suggest new hypotheses far more quickly than traditional methods. This chart illustrates the impact. Research that once took 10 years is compressed into 2 months. Yet, current computers cannot solve every problem. Challenges like climate modeling remain out of reach. Quantum computing is built to handle these specific, impossible calculations. By utilizing the properties of quantum mechanics, these systems provide the computational power needed to resolve complex logistics and scientific modeling problems within a human lifespan. For a researcher tackling the universe's most difficult questions, this shift marks the transition from an unsolvable mystery to an achievable goal. Beyond the laboratory, we are also removing the day-to-day friction that drains an individual's mental energy. AI tools are now automating the repetitive, data-intensive tasks that once filled a workday, reclaiming hours of lost time. This allows individuals to focus their mental energy where it is most effective, on high-level strategy and the conceptual breakthroughs that define meaningful work. Generative AI acts as a collaborative partner in this process. It helps overcome creative blocks by rapidly iterating on new designs, musical compositions, or scientific hypotheses, allowing a creator to explore more ideas in a single afternoon than they previously could in a month. This increase in speed applies to the creators themselves. AI-powered learning tools shorten the time it takes to master new skills, while the same computational power is accelerating research into personalized medicine, research that aims to extend the healthy years we have to pursue our goals. By outsourcing the mundane and augmenting our creative output, the human mind moves from managing tasks to solving the problems only it can solve. Removing these administrative and computational bottlenecks changes who is actually able to change the world. In the past, executing a project with global impact required the infrastructure and multi-decade commitment of a massive institution. This scale shows the shift. Today, the tools that were once exclusive to large organizations are available to individuals. A single researcher or a small team can now undertake projects of significant scale and impact without needing a lifetime of accumulated institutional resources. The traditional timeline for a life's work has been broken. Finality. Our highest ambitions no longer require a lifetime of waiting, because our tools are finally moving at the speed of human imagination.